Hey guys, so today we are revisiting this murdered compressor from a video I did last week about the compressor where all three terminals blew out. Filter dryer was on the hot gas discharge line. The requoted job was approved, so I'm here today to repipe everything, switch out this compressor, contactor, filter dryer of course, and straighten everything out as best I can. So it's warm out, it's sunny out. I got my umbrella up. I got my cart full of tools down there. All you new guys out there, after you've been doing this for a couple years, you're going to want to invest in a cart like this, or at least a wagon, so you don't have to carry all this stuff across the rooftop. If you look behind me, that's a good, I don't know, 30, 40 feet. And even though I do need more cardio, I prefer not to get my cardio on rooftops carrying hundreds and hundreds of pounds of equipment. So I usually try to bring up my little cart, roll it across the roof, save my back a couple more years, you know. But let me flip this camera around and just revisit this situation we're dealing with before we get started, all right? Here is our little Trane unit, our 5-ton unit. As you can tell, everything's got a coating of oil on it, which is normal for this situation. Again, remember, we blew out all three terminals of our compressor. This was melted. Now, I was thinking about this on my last video. If you remember, I had pointed out this little pinhole leak. And for a couple days, that bothered me of how we had a pinhole leak. And I got to looking at it in my pictures, and it didn't look like a rub out. So I had a new theory. My new theory was that this blew off and maybe spun around, touched right there, because that looks almost like an arc mark. So that's what I think happened. I don't think it was a rub out. From my previous video, I think I said it was a rub out or just a pinhole leak or something, but anyway, I digress. So the first thing we're going to do is cut away a majority of this piping. This is all going to be repiped properly. This line right here and this line back here, we're going to have to repipe this hot gas discharge line. Make everything match up the way it should have. And we'll have to put a new filter dryer in over here, of course. So I'm going to cut the copper out. I'm going to isolate the condenser, blow through it with nitrogen, get as much of that contaminated oil out of the system as I possibly can. We'll have a better chance of not recontaminating the new compressor if we can get as much oil out of this oil-logged condenser as possible. Because I'm 99% sure there's acid in the system, and the acid lies in the oil. So if I can get all or as much oil out as I can, then we have a better chance of, like I said, not recontaminating the system. So I'm going to isolate the condenser, blow that out, do the same with the evaporator. We'll blow that out. I believe this is a TXV system. I'll double check, but if it is a TXV system, it's going to be wide open anyway, because the TXV just thinks that it should open up because it's not sensing any superheat at the end of its suction line. So let me get a few things set up here, guys, and I'll bring you back when I start blowing some nitrogen through this condenser. We'll see how much oil is really in there. All right. Our condenser is isolated, and what I'm going to do is I'm going to blow through this high side. Actually, this, I believe, is our, yeah, this would be our liquid side. I'm going to blow through here. I just got 50 pounds of pressure on it. I don't want the oil to really come shooting out. Yummy. Yeah, there's a little bit of oil left in there. I'm no super tech, but I'm pretty sure the condenser shouldn't have that much oil in it. And I don't believe the oil should look like coffee grounds. Now I know you guys can't smell it, but it's got sort of a bitter smell to it. So I would assume that smell is obviously acid or whatever is in the system. You guys think Tide Pods will get that oil out of that cloth, that towel that I got there? I have a feeling that's not going to wash out very easily. Really didn't think there'd be this much oil in there. I'm going to crank it up a little bit. Move you guys over here a little bit because we're getting a ton of oil blowing out there. Alright, let's try to do this here. When I was first coming up in the trades, this is how I was taught to recover. Just get a towel, cut a line, throw the towel over the line, and let it bleed out. Obviously, we know better now, don't we? Well, that was my full tank of nitrogen. We still got some more oil to blow out of there. Alright guys, I'm going to shut this off for a little bit, go refill my tank of nitrogen, and then we will blow some more oil out. Here's where we stand, guys. So, as you can tell, I got my compressor cut out. My lines are all cleaned up. There's my condenser. I blew through the evaporator and the condenser. I got a bunch of oil out. There's just a pile of rags that I use to clean up after myself. I like to try to clean up as much oil as I can off the floor of these units. I got most of it out, but it's not perfect, but it's a little bit of OCD that I have. So now I'm just waiting on my compressor. I have another technician bringing me the compressor, contactor, filter dryer, all that. I'm really trying to push my customer to replace that condensing fan motor. They rejected my initial quote with that condensing fan motor. But today, now that I'm looking at it more, I really stressed the need to replace that. Common sense is you don't put a $1,500 compressor in if you're not going to change the 20-year-old condensing fan motor above it, because you run the risk of having that condensing fan motor fail, and then our brand new compressor will overheat, and then in a little while we're back to square one again. So I got everything all cleaned up. as soon as I get the new compressor in here, we're gonna set it in place, start measuring some pipes, and yeah, and we'll go from there. All right, guys. So I'll bring you back in just a little bit. Tech tip of the day. Down there, you'll see our unit that we're working on today, and you remember our piping was a mess, and I just basically gutted all the piping out of it. So I came down here to this twin unit to try to pipe the unit I'm working on up exactly as it should be from the factory. So I just came over here and kind of measured this pipe, this hot gas discharge line, and we basically got it right on. So tip of the day, if you're ever in a situation like this and the piping is a complete mess and you don't know what you're gonna do, see if there's a twin to that unit and try to match it up best you can. All right? All right, guys, here's a look at our piping job right before we get everything brazed up. We got our high side pressure switch port right there. That's where our low side pressure switch port's gonna be. Right down here, we're gonna have our service port, and I'm gonna put some couplers on here and strap this in place. We tried to do this without using a lot of couplers. We just swedged out our ends, put those in there. If you guys are wondering, that is the correct filter dryer from the factory. We just had to put a couple reducers on there, but I did verify that is the correct dryer. So everything looks nice and shiny. We're gonna braze it in place and pressurize it in just a minute. All right, real quick, just so the YouTube police don't come after me, just to show you that we are brazing with nitrogen. You can see the little bead in there floating, 3 to 5 psi, hooked up to one hose going into our suction side. And the idea is it's going to go through our suction side into the compressor. You can kind of feel it coming out here. It's going to come out here, go through our condenser, through our liquid line, through the dryer, to the evaporator, and we'll basically have all our bases covered. All right? Looks pretty good. I don't even know if the factory could do that good.
Let's transfer this rag there so that I can get both to the side.
You're doing that second service port? As you can tell, we got everything brazed in place. We are currently sitting at 150 psi. We have no leaks anywhere. Our piping came out pretty good. Nice and shiny. Everything fit the way we wanted it to. One thing I did want to point out to you guys, I've never seen this before, so I figured it's worth sharing. This is the wiring to our old compressor, and you'll notice our black wire goes to the incoming side of our contactor. Now, I had just assumed that that was wired incorrectly, so come over here to our schematic. Right down here, compressor 1, we follow our black. So our black does go directly to line voltage. Our contactor right there and right there, that just cuts off our blue and red power lines. So I don't really know what that black line is constantly powered for. I guess maybe crankcase heater, maybe if it has constant power to it, that winding stays a little warm to keep refrigerant from migrating into the compressor during the off cycle. Yeah, I'm not real sure. So if anybody out there watching knows exactly why that black line is powered continuously, let me know. I'm curious to find out. But all right, guys, we're gonna let this sit under pressure for a little while longer, and then we'll pull a vacuum in. Make sure everything's really nice and tight. Here's where we're at. Pulled a vacuum, got it down to 170, valved it off. I valved this off at my gauge, So this is literally the lowest point in my entire system. That's what we pulled through. Yes, I did leave the Schrader cores in the high and the low side. I know that is a restriction, and I also know pulling through my gauges is a restriction. However, the system's so small, it doesn't really warrant the use of the True Blue hoses that I do not own yet. But we did get 170 microns out of this system. It's probably been valved off for about 10 minutes-ish, 10-15 minutes, and we're holding tight at 200. So we're gonna go ahead and charge this thing up. Takes 4.9 pounds of R22, and we use the real R22. We're not doing any sort of drop-ins or anything like that, so let's charge it up. Now, whenever I'm charging up a system like this, I usually account for at least 1 to 2 ounces of refrigerant per hose, assuming that maybe I can pull maybe a ½ ounce out of each hose when I disconnect my gauges properly. So we're gonna go over just a little bit. Just about 3 pounds. It's cruising along, so we should have no problem getting to 4. 4 pounds, 2 ounces. And I wanna get about 4 pounds. I figure 4 pounds, 12 ounces should be just enough. Yeah, we may have to pull the rest in through the low side. All right, looks like we have to pull the rest in through the low side. We're stopping at about 4, if you can see that on camera. 4 pounds, 3 ounces. So what we're gonna do, what my buddy Jason here is gonna do, we are going to valve off our low side like so, and valve off our high side, and then you open up that low side on that gauge, Jason, just a little tiny bit, and then now our gauges are basically purged, so you can pull that micron gauge off there if you don't mind. Be careful, there's a little bit of refrigerant that's going to come out of there. That's what we call de minimis maximus. Alright guys, we're all just powered it on a second ago, and I think it's running backwards, so we're going to power it on again just so you can hear it running backwards, and then we'll switch some wires, and then we'll fire it up again so you can hear the difference. See? That right there sounds like it's running backwards. You see we have no differential on our pressures. So now what we're gonna do is we're gonna switch 2 legs of power, and then we'll start it back up. We got 2 legs of our compressor switched around, so let's see how it sounds now. It's a much smoother sound right off the bat, and we're immediately getting, let me close this off, there we go, immediately getting a pressure differential. Of course, my low side is now pumping down into a vacuum, and we are shutting off on low pressure. All right, that's different. Want to kill that, Jason? Huh. Well, we are fully charged, so keep in mind we did flush the system with 2 tanks of nitrogen and RX11. So let me pull this panel open, and we're going to check our metering device. We might be plugged up. Picking up where we just left off. So our system basically just pumped itself down and shut off on the low pressure, and we were short cycling on the low pressure switch for a few minutes. So here's what we got going on, I think. Right here, this is our suction line. This line right here, this is our liquid line, and in each one of these little lines right here, pinched off inside here, is a little piston. This is our metering device. So we have pistons all throughout here. So they feed in through here, go through our evaporator, come back out to our suction header, and then our suction header goes back to our compressor. Now, when I had the old compressor out, I isolated the evaporator and I blew nitrogen through it, and it came out the other side along with some oil. Hindsight, I think maybe I should have had more pressure coming out, but I did get a bunch of oil and a bunch of other garbage out of there. Like I said, I went through 2 tanks of nitrogen, probably about a tank and a half on the condenser, about another tank or a half tank on the evaporator. But what I'm thinking maybe is that I was just blowing through maybe half of these instead of all of them. So what I'm gonna do, and this is probably not recommended by the manufacturer, but I'm gonna take a heat source and warm these up a little bit. You can figure out what kind of heat source, but I'm gonna take a heat source, warm these up a little bit, and kind of just tap on them a little bit, see if I can't free up some of that oil, some of that garbage that might be in there. And yeah, well, we'll go from there. I might end up reclaiming this charge and re-isolating this evaporator. If I do that, I'll probably just end up cutting it right here, and then we'll just have to flush it out again, and then braze it all back together and do this whole process over. So it may be a long day, guys. So I went through, I heated all these little pistons up with the heat source, and as far as I can tell, it really didn't do anything. We're not down low enough where our low pressure switch is cycling us off, but we really shouldn't have a negative 20-degree evaporator. And you can tell right here where some of these are starting to frost over. I believe these are the ones that are probably blocked off, or maybe not. If I had a thermal imaging camera, I would be able to see a lot better which circuits are working and which are not. We got frost on this one, frost on this one, frost on this one, and frost on this one. None of these other ones are frosted up. So it could be that these are all blocked off and these are open, and since there's so much pressure going through there, because this machine's trying to put enough pressure through there to feed this entire evaporator, there's so much pressure going through here, maybe it's just boiling off right here at the inlet of the evaporator. So it looks like we might have to isolate this evaporator and try to get those pistons clear. If not, what we have to come back and do is we have to cut this liquid header. We have to cut it right off and then try to braze in a new liquid header with pistons pre-installed. So let me call our person who's paying the bill and see what kind of options we got. Here's where we stand, guys. So this is all plugged up. I did take a heat source, like I said, tried to free it up, but that didn't work. That failed. So I have two options here. I was kind of bouncing ideas off another technician. First idea was to just replace this liquid header, and in order to do that, of course, we'd have to cut this, cut apart this suction line just to get this liquid header out of the way. I'd have to go through it. I'd have to cut in between each one of these tubes so I could unbraze it out of the evaporator, because of course you can't unbraze this whole thing at the same time because there's, I don't know, about 10 of these little tubes going in the evaporator. So that's a very labor intensive option, and I still might not get all the contaminants out of that evaporator. Even if I put a new header in there, we purge it, blow nitrogen through, RX11, acid scavenger, whatever I can blow through there, I still might not get everything out of there. So our other option, which is probably less labor intensive, is just to swap out this evaporator, assuming that it comes with new suction and liquid headers. So that I'm going to have to talk to the person who pays the bill on this account and run those two options by them and see what they want to do. So it looks like this went from a part 2 to it's going to be a part 3 to this video. So we'll go from there and have to come back here and swap this out, I suppose. Yeah, so something I've never seen in real life. I've read about this, heard about these blocking up, and really it's no surprise. I mean, like you know, like I said before, there was all sorts of contaminants in that condensing coil from that filter dryer being in the wrong spot. So who knows what ended up in that evaporator in those little tiny orifices. But anyway, guys, that's all for now. Assuming that the customer does want to replace that evaporator, of course, they've already invested quite a bit of money on the rest of this, so they probably will. We'll come back and we'll film what I hope to be the end of this trilogy. All right, guys? Thanks for watching. And yeah, we'll see you on the next one, all right?